Sorry, I know it goes against your feelings. All right. So I am on page 129. So it says find the proportion. 1, 2, and 3 are all going to be done the same way. And what I'll do on the test or quiz to help you out on this, I will make sure the link is outside. So basically where it is right now is if you go into week 15, which is last week, but I'll make sure it's on the main page. It's called the chi-square test on Desmos. And this is how easy this is to use. There's one thing I have to change. I have to change this. I need to change it to... Let me change that. Speed. All right. So for problem number 1, it said find the chi-squared curve with 8 degrees of freedom that is greater than 20. So on the slider, you go degrees of freedom 8, and then go up to 20. So you have a p-value of 0.01. I mean, it's as simple as it is to use. For problem number 2, it says 15 degrees of freedom. So you slide over, you change your degrees of freedom to 15. And they wanted it to be greater than 20. So you're talking about 0.17 is your p-value. And then your degrees of freedom is 25. And it kind of goes off the screen. So what you want to do once you get to 25 is zoom out a little bit. And then my chi-squared is 20. Oh, they want to go less than 20. So what you would do on this one is you take your p-value, which is 0.75. You go 1 minus 0.75 because you want to go to the left. So it's 0.25 as a p-value. Okay? But again, I will make sure that's available for you on Desmos. Oh, and friends, I'm so sorry. I don't have a 7-1 to 7-3 quiz. Sorry. I know I'm going to get phone calls. I don't have the 7-1 to 7-3 quiz. I don't have one. So we won't have a quiz this week. Sorry. I know most of you woke up this morning going, dude, can't wait for that quiz, but all right. All right, here we go to Netflix. It says Netflix has 11 movie categories. They have drama, comedy, horror, etc. They wish to test whether the distribution of movie types it rents has changed since 2010. They conduct a chi-squared test, obtain a chi-squared test statistic. Sum of all the chi-squared values is 23.6. All right. Shh. Some of you are off task. Won't mention any names. All right. So they tell us there's 11 categories. All right, Bobby. This one's for you. If I have 11 categories, what's my degrees of freedom? Yeah, there you go. So degrees of freedom would be 10 in this case. All right. All right. So, hey, what's happening? Good to see you, brother. All right. All right, so they want us to So we're going to call our mu movie types. So our alternative, our null and our alternative will be as is. So mu is equal to the categories. And then mu is not equal to the categories. All right. How many degrees of freedom do we have? Well, here's number 5 right there. Degrees of freedom would be 10. Calculate the p-value. And so we'll jump back onto Desmos. And they tell us that we have 10 degrees of freedom. And they tell us our chi-squared value is bigger than that. So what I'm going to do is you have to come down here, you have to change it a little bit. So they tell us that our summation was 23.6. All right, I'm going 23.5. So this tells us that we have a p-value of 0.009. Okay, so if I have a p-value of 0.009 and they want, that's a 9, and they want us to, they say we have an alpha that we're testing against of 0.04. 0.009 is smaller than 0.04, so we are going to reject the null. We're rejecting the null because our p-value is smaller. We have evidence against. Hey, good to see you, buddy. Evidence against our null. Okay? And then number 8 says, would a higher chi-square test make it easier or harder to reject the null? So the larger this is, so this is the sum. Guys, the larger this chi-squared value, the larger our sum of our column would be, the easier it is to reject the null. Okay? And then what kind of assumptions are met? I mean, they tell us we have 11 movie categories. The hard thing about this, we don't necessarily know how many movies are in each category. We'd probably have to find that in order to base it upon here. I mean, if you had a movie category of, say, drama, and there was one drama, but you had 255,000 comedies, it's kind of hard to go with, okay? So we just don't have that information there. All right, page 130. Page 130 says wildlife officials monitor changes in the ecosystem in the parks. In Cherry Creek State Park, the distribution of snakes throughout is as follows. So we have garter, bull, racer, and rattlesnake as 60%, 20%, 10%, 10%. Wildlife officials tour various roads and trails frequently, and they keep tabs on the snakes they observe. And their raw count, they had 38 garter, 25 bull, 7 racer, and 4 rattlesnakes. So we can go ahead and excuse me. We can say that our null and our alternative, we can say that mu is snake percents. So we can say snake percents are equal to the observed, or we could say snake percent is different than our observed. Okay? All right. So show a chart. Here's how we're going to do the chart. We're just going to jump on to regular Desmos. And I'm going to create a table. On my table, my friends, I'm going to change my percent, my 60%, I'm going to change it to a decimal. So that's 0.60. And then 20% is 0.20. 0.10 for 10%, and 0.10 for 10%. Those are our 4 different types of species of snakes. And then we have to add up. Let's see, how many snakes do we have total? We have 38. Oops, clear. 38 plus 25 plus 7 plus 4. So we have 74 snakes total. So I'm going to have 38 divided by 74. We're going to have 25 divided by 74. We're going to have 7 divided by 74. And we're going to have 4 divided by 74. Oops, 4 divided by 74. So your x1 is your expected value, your y1 is your observed. So let's do our information. So I'm going to take my x sub 1 minus y sub 1, square that, divided by my expected value. My expected value is x sub 1. And so if I were to add up those values there, so I get 0.012 plus 0.012 plus 0.095 plus 0.12329 plus 0.021. So if I add up that whole column of the purple, the far right, I come up with 0.128. That's my chi-squared sum. All right, and then calculate the p-value. So our p-value, we're going to go to our chi-squared Desmos here. We have 4 categories of snakes, so my degrees of freedom would be? Anybody? We have 3 degrees of freedom because we have 4 categories. My chi-squared is going to be roughly 0.13. I don't even know if I can get there. It says I'm going to go about 0.1. So we have a p-value of 0.99. Okay, so if we are comparing our 0.99 to our alpha of 0.10, 0.99 is far greater than 0.10. So what that means on this particular problem, so we get 0.99 is our p-value. Our alpha value to compare it to is 0.10. So being that this is larger, we are going to fail to reject the null. We did not find strong evidence against the null. Something like that. That's looking bad. Okay. So that takes care of you all there. So being you're here and you witnessed the problems, you get the points for the homework. Hopefully you plagiarized it. And if you're not here during one of these, make sure you watch the video and copy it down so you can show me. Oops, not here. Malia's over there, okay. Schaefer. Nicky, not here. Harmon here. Natalie. All right, cool. All right, we're good in the hood. All right. So, being that we're not doing a 7173 quiz, I'm going to just go right on to Unit 4. So I'm on page 53. With me on this adventure? All right. All right. So we're going back to the problem that talked about, you had the Atlantic, the Pacific, and the Indian Oceans. You had categories 1, 2, 3, 4, and 5 hurricanes. And they have 20, 16, 10. And then you have a total of 46. 684 or 1684 for a total of 28. 1062. So you get 18. 551. So you get 11. 241. 7. So you have 53 here total. 39 and 18. For a total of 110 hurricanes. All right. So, it says earlier this year we studied probability and contingency tables, which is this case. The following was based on data related to the intensity of hurricanes throughout the world. We might wonder if the intensity of hurricanes is independent to the ocean where it occurs. That is, does the likelihood of an intense hurricane depend upon the ocean where it took place? It isn't enough to calculate individual probabilities because it is only the sample of hurricanes. The chart does not represent the hurricanes and could not or ever will occur there. Therefore, we need to test to see if we have strong statistical significance, whether it's strong enough evidence that to conclude the intensity of a hurricane is related in some way to the ocean. So basically, based off this, they're saying that we have a null and an alternative, and they're saying oceans and hurricanes are independent, like it doesn't matter, and then ocean and hurricane are dependent. And so as we go through this, basically you can reject the null. We find strong evidence that the ocean and hurricane intensity are dependent. We fail to reject the null. We fail to find strong evidence that the ocean and hurricane intensity are independent. So the chi-squared test cannot find strong evidence for anything more than independence. We won't have strong evidence for a particular relationship in the table. For example, the chi-squared cannot be used to find strong evidence that Category 5 hurricanes are more likely in the Pacific Ocean. That is a test for an entire contingency table. Either the variables are dependent or not. So hurricane intensity with level 5s are, they have 5 levels. So you have Category 1, 2, 3, 4, 5. Oceans are 3, Atlantic, Pacific, and Indian. So there's 15 different categories and oceans that they occur in. So what you're going to do is, if you wanted to figure out the expected is going to be the row total times the column total over the total hurricanes. Okay? So in our case, if you looked at the Atlantic Category 1, it's basically, I think they have actually backwards, 53 times 46 over 110, but it doesn't matter if 46, 53 are flip-flopped. This comes out to 22.2. Okay? So in other words, if the ocean intensity are independent, we'd expect 22.2% Atlantic Category 1 hurricanes. We actually counted it a bit less, but it provides some evidence that the hurricanes are independent. For the method for establishing the chi-squared, it's just the observed minus the expected quantity squared over the expected. So we've done that over and over. So if we basically went through this, this would give us 20 minus 22.2 divided by quantity squared over 22.2, which comes out to 0.218. And so in this case, it says, again, the chi-squared value is the measure of the difference between the actual hurricane count and the count we'd expect, and the two variables are independent. The higher the chi-squared value, the more evidence we have that the two variables are actually dependent upon each other. In the next section, we'll proceed with the rest of the chi-squared test. All right. So being that we're not doing a 7-1 to 7-3 quiz, we're skipping that page. But I'd like you to take a look at page 133, 134 for next time. We'll go over that just like we've been doing. But that's what I got. Okay? Some of you owe me some quizzes, so I'm going to give you the opportunity to finish it up.